Our fourth problem deals with solubility, and it states that the solubility of CaSO4, or calcium sulfate, is found to be 0.67 grams per liter. Calculate the value of the KSP for the calcium sulfate. And here we have our reaction, and all we need to solve for this problem is this expression here. But for this reaction, it would look something more like this on the bottom. So to start off, first we need to make an ice table, but instead of finding rates, we're finding solubility. So we don't know the solubility of KSO4, that's what we're solving for, and we're assuming that the solubility for calcium and SO4 is 0. So normally we would write an X here for the rate, but since we're finding solubility, it would be an S. And CaSO4 dissolves into the calcium and the sulfate, so that would be a negative. And these, since this is creating more of the reactants, would be a positive. So now for our equation, we have S times S, or it would be equal to S squared. So now that we have this, all we need to do is first translate 0.67 grams per liters into moles per liters, and that's just simple conversions. We have 0.67 grams of CaSO4 over 1 liter of solution times 1 mole of CaSO4, which is what we're looking for, over the molar mass of CaSO4 in grams. These cancel out, and we're left with 4.9 times 10 to the negative 3 moles per liter. And this number right here will be our S. So next, the problem is pretty easy. All you have to do is plug into this equation. So we have KSP is equal to S to the 2, which would be our 4.9 times 10 to the negative 3rd squared. When you plug that into the calculator, it gives us 2.4 times 10 to the negative 5th. And this is the value of KSP for calcium sulfate.